Hello, this is Achu Patel. This is my AP Chemistry final project question walkthrough video. Today we're going to be doing an acid-base titration problem. And here we are told that we have a 50 milliliter sample of 1 molar HCl solution, and it is being titrated with a 0.5 molar NaOH solution. So for part A, we're being asked to calculate the volume of the NaOH solution needed to reach the equivalence point. Now, we know that to find that the equivalence point, the moles of a base have to equal the moles of acid. So what we're going to do is we're going to do M1V1 is going to equal M2V2. So we are told that we have 50 milliliters of HCl, and we are told that we have 1 molar solution of HCl. And we are told that we have 0.5 molar solution of NaOH, but we do not know what the volume of NaOH is, and that's what we're trying to find. So we just basically have to solve for x. So what we're going to end up doing is we're going to divide by 0.5 on both sides. And what's going to end up happening is we are going to get a x value of 100, which basically means our volume of NaOH is going to equal 100. So this would be the answer to part A. Now, let's move on to part B. So for part B, we're being asked, what is the pH of the HCl solution before any NaOH is added? So we can use the information given to us. We have a 50 milliliter, we don't need any of that. We just need the ones. So we know that we have 1 molar solution of HCl, and we can use this information with the equation HCl will dissociate into H plus Cl minus. We can use this equation because we know that HCl is a strong acid. It dissociates completely in solution. So if we have 1 molar of HCl, that's going to produce 1 molar of H plus and 1 molar of Cl minus. Now, we know that to find pH, we can use the equation pH equals negative log the concentration of H plus ions. And because we have the concentration of 1, we can plug that straight into here. So pH equals negative log of 1. This will just give us an answer of 0. All right. Let's move on to part C. All right, so we're being asked to find what is the pH of the solution after 30 milliliters of NaOH has been added. So when we're being asked this type of question, we want to create an equation for the titration. So HCl plus NaOH will give us water and the salt NaCl. So first things first, what I want to do is I want to make a ICF table. This will help us find our answer, and I want to find how many moles of HCl and NaOH I have. So the way I can do that is just multiplying the milliliters, or dividing the milliliters by the concentration. So I know that I have 50 milliliters of HCl, and all I have to do to find the amount of moles is to divide by the concentration. Now, personally, I like to use millimoles. So I will do 1 millimole of HCl over 1 milliliter of HCl, which will give us 50 millimoles. Millimoles. All right, and then now we would do the same thing with NaOH. So what we're going to do is we're going to do 30 milliliters over 1 times 0.5 millimoles over 1 milliliter of NaOH. Milliliters are going to cancel, and we're going to get 15 millimoles of NaOH. Now all we have to do is to subtract everything by 15, because 15 is the smallest number. So that's only for the reactant side. For the product side, we're going to add 15 millimoles to the NaCl. We don't include water in our equation or in our process, so we don't have to really care about that. But because we're only finding pH, we don't have to care about the products. We only care about reactants. So in our final part, we're going to have 0 concentration of NaOH left, and we're going to have 35 millimoles of HCl. Now, what we're going to end up doing is we are going to get, we're going to find the new concentration of HCl in the solution after the NaOH has been added. So we're just going to take 35 millimoles of HCl, and we are going to, sorry, I just blanked there, that was bad. We are going to divide by the total amount of milliliters that we have. So for HCl, we originally had 50 milliliters, and for NaOH, we added 30 milliliters. So we're going to divide by 80 milliliters. So I'm just going to grab a new paper real quick. So we had 35 millimoles of HCl. We're going to divide it by 80 milliliters, which is our total milliliters of the solution. And what we should get when we do that is 0.4375 molarity of HCl. Now, like the last problem, we can basically use the same thing, where we can assume that if this is the molarity of HCl, we can also assume that this is going to be the same molarity for H+. So we can again use pH equals negative log of the concentration of H+, and by plugging in 0.4375, we would get a pH of 0.359. So that is the answer to part C. Now we have part D, which is very simple, and that is what is the pH of the equivalence point. Now, for this problem, we're lucky, it's pretty simple because we have HCl, which is a strong acid, and NaOH, which is a strong base. We know that for strong acid, strong base titrations, that the equivalence point will have a pH of 7. That is it for this practice problem. Thank you for watching, and yeah.